So at this point, it's my pleasure to begin the first session of the day with our keynote speaker, Dr. Harrison Fraker. Professor Fraker is a professor of the Graduate School and Professor Emeritus of Architecture and Urban Design at UC Berkeley. He was educated as an architect and urban designer at Princeton and Cambridge universities and is recognized as a pioneer in passive solar, daylighting, and sustainable design research while he was teaching at Princeton for 15 years. He was awarded the Distinguished Service Medal for creating a new College of Architecture and Landscape Architecture at the University of Minnesota and appointed the founding dean. He was granted fellowship at the AIA for his award-winning career bridging education and practice. He has published seminal articles on sustainable design and urban design principles for transit-oriented development, including the China eco-block concept. He stepped down as the 5th dean of CED in June. That's 2008. It says 1908 here. I think that is a testament to your sustainability. After 2.5 years, by the way, I think we just copied and pasted from whatever we got. And he serves on the Places Journal Executive Committee. His research on sustainable communities is summarized in The Hidden Potential of Sustainable Neighborhoods, 2013 Island Press. He's past chair of the Energy Resources Group at UC Berkeley and served as the Axon Johnson Guest Professor in the Sustainable Urban Design Master's Program at Lund University, and the list of achievements goes on and on. But to maximize our time with him, Professor Harrison Fraker, please join me in welcoming.
Thank you very much for inviting me. I'd like to thank the organizers who were just introduced. Diamond Development, thank you very much. And UC Davis for inviting me from one of your sister universities. I want to talk to you today about the value and the challenges of integrated systems thinking related to some experiences that I have had over the last, believe it or not, now 20 years. So, the experiences that I've had, number one, when I stepped down as the dean in 2008, up until that time, for almost 8 years, I've been trying to build an eco-block sustainable community in China. And it was always, we'd get just to the threshold and it would be canceled. So I decided to travel around the world and visit all of the first generation sustainable communities that I could find, and then write a book about it. And I'm going to report on those today because they actually provide a baseline for the work that has proceeded since. Also, when I was the chair of ERG at Berkeley, we decided to try to do an eco-block and to do the hardest one possible, which is to retrofit a neighborhood to make it zero energy, zero carbon, and to make an actual microgrid with its own storage. So those are the things I'm using as my lessons learned. But to start, this is a diagram that we drew for the eco-blocks in China. So it's trying to combine energy, water, and waste design thinking to create sustainability. This diagram is so out of date, and you'll see at the end that there's so many more things that need to be added to this Venn diagram, not the least of which is transportation, food, people, financing, social acceptance, policy frameworks, and institutional organization. That's the real integrated systems design problem. So a lot of the stuff I'm going to talk about very quickly is all summarized in my book, The Hidden Potential of Sustainable Neighborhoods. It was ahead of its time. What's interesting is when it was first published, not many people bought it. Now lots of people are buying it. So it just shows you that the idea of this integrated approach of systems thinking works at the neighborhood scale. Most of you know about these projects because West Village was modeled after them. And I even have a chapter on West Village in this book, if you'd like to see it. It's the first chapter about West Village. So these are the neighborhoods, Boawan and Hammarby in Sweden, Kronsberg and Vauban and Freiburg. We don't have to go through this, but I did analyze process and plan, transportation, urban form, green space, energy, water, waste, social agenda, and resilience for all 4 of these neighborhoods. So let me just quickly summarize the lessons learned from process. First of all, 3 out of these 4, Boawan, Hammarby, and Kronsberg, all had special conditions that provided lots of extra funding to promote the integrated systems thinking across agencies and departments. Without that, this wouldn't have happened. So the question is, in normal practice, where do we get the funding to ask people to do things differently? That's one really important lesson. The other thing was the cities in Europe own the land, and they can be horizontal developers. They build the infrastructure, they build the streets and everything, and they can demand the agencies and the utilities to work together in an integrated way. We don't necessarily have that. That's an institutional challenge. The other thing was the participation by the local community was absolutely critical in achieving their targets. When you didn't have it, they didn't make it. When you did have it, they did. Very, very important lessons. Transportation was key. I don't have to go through these rules here. You have to either have a tram or bus access, close to all the units, good stops with information about things, short headways, a pedestrian environment to get there, fine-grained streets, dedicated bikes so you have a larger bike shed, a collecting area, limited parking, and it has to be affordable. We all know that. I don't want to go into the urban form. It could be a whole lecture. The main takeaway from the urban form has to do with that you need to have a street block building type density that can support transportation, local shopping and commerce, institutions, schools, so you have an integrated community. If you don't have enough density, it's kind of a bedroom situation. So that's very, very important. I don't need to go through this quickly because I'm trying to make up time. They're pretty cool looking places. I could talk a lot about the design differences and how interesting they are. This is Hammarby, beautiful lake that they're around. This is on the edge of the countryside, progression from urban to country. This is the wonderful Vauban project, which I could spend a long time talking about because it really highlights cooperative Baugruppen construction of the whole neighborhood, and they're the best performers. One key thing which is essential for these sustainable communities is the provision of green space. Every single one of these have much more green space than is typical. You can see it quickly in these diagrams, and there's a specification. So many square feet of green space in such and such a distance from units, and they even said half of the surface area needed to be living. So it has been one of the biggest reasons why these communities are so cherished, is while they have an urban density, they have incredible access to the green. What does that remind you of? UC Davis. I could spend a lot of time on this diagram. This is the energy performance. And what's so interesting about these neighborhoods, the first one, Boawan, has wind machines driving ground source heat pumps. They did a terrible job of oh, by the way, I only went to these places because I had performance data. I could get real results. So they had a target of roughly 100 kilowatt hours per meter squared per year. Boawan missed it by 50%. That's because they had to rush the construction and there was too much air infiltration. But they had such a good local renewable resource that they're 100% renewable. If you take Hammarby, no wind, no sun, the best example of using waste to generate energy. A very seminal discovery on my part here. They also missed their energy efficiency target by 50%. That's because they all wanted to have big windows and views of the lake. And now we take Kronsberg. We're now in Germany. They met the energy efficiency targets. How did they do it? They required every builder simulate the performance of their units according to one program and prove that they were going to make it. Then they had to have a blower door test to show that the air infiltration rate met the standards that they had. They met it. They were also pretty early. They had 3 wind machines in combination with combined heat and power generation. So they're about 50% renewable. Then we come to Vauban. Amazing. Incredible process. I'd love to lecture on this for a long time. They sold the development plots to cooperative housing groups called Baugruppen, and they were able to be their developers, contractors, designers, and they shared information and competed. Every single one of these things beat the energy targets. And then they used solar and then a wood chip to combine heat and power for the neighborhood. So it's the closest thing to a complete job. What about water? Not too creative in the water part. They treated stormwater, they collected it, held on to it, used it as a design feature. It became an amazing attraction for all of the communities. So stormwater, you know it in West Village, can be a real identifying quality for the neighborhood that people value. An important thing to include. How am I doing? We could talk about this diagram. As a result of those things, what I did is I showed all the waste, which is in the gray area in the US, how you can use combustible and biogas to run electric turbines, and you can see how you can get energy from waste. As the base there, you can do efficiency aggressively, and then you have a very small amount you need to make up with renewables. Suddenly, it's affordable, easy to achieve, etc. Let's talk about the eco-block quickly. So, frustrated in China, wrote this book, chair of ERG. Let's make a difference. Let's see if we can't do an eco-block in Oakland as a retrofit project. Lots of people involved, Berkeley faculty, Stanford faculty, professionals in all the disciplines, lots of money from engineering company and foundations to help make this. It's a 30-person interdisciplinary team, a lot of work. Why are we interested in retrofitting these first ring suburbs? It represents 40% of the housing stock in California. If we don't reduce the carbon emissions of that part of our economy, we have problems. And we don't get really good energy efficiency in those areas because if you do it by itself, it doesn't pay out. So you could read through this quickly. As I said, 40 to 50% of the housing stock. Could we get these to zero energy, zero carbon, low water, and EV charging vehicles? That was the question. And could we do it in a way that was economical and scalable? I'm not gonna. So this is the system. It's pretty simple. The first thing you do is you do deep energy efficiency retrofits, including fuel switching from gas to electric for heating and hot water. Then you have community solar on those roofs that have good exposure. It's a DC backbone, so you don't have the inverters, to a vacuum flywheel storage. It then goes back to EV charging or to street lights. Then it goes to an inverter, can go to the grid or go back to the houses. So this is a microgrid, a DC microgrid concept. You can see it running around a block in Oakland with one kind of little service thing. What about the water? Again, the first thing that's affordable is water conservation, a huge thing to do. Rainwater, believe it or not, even though we have so little of it, actually pencils out for use in the homes if you treat it and put it right back into potable. There's some zoning code problems. The question is mining the sewer. We looked at this initially because we think the microclimates, especially in the Central Valley of these neighborhoods, are really critical. They need 10 times as many trees. Where do you get the water? What's the biggest water resource in California? Wastewater. Mine the sewer, treat the wastewater, change the microclimate. That's integrated systems thinking. Almost there. So here are all the benefits. Cash flow savings from the utility bills pay for all the improvements. They fund the conversion to locally distributed renewable energy with built-in storage that really helps the load profile for the utility. The energy savings from the efficiency retrofits creates enough capacity in the PVs to charge EVs for roughly 40% of the vehicle miles traveled. The renewable supply is enough to allow the fuel switching, increased comfort in the home, is really important. Increased real estate value because we've upgraded these things. So what happens here is the integrated systems thinking about the financing. If you just try to do the energy efficiency, it's too expensive. If you create enough capacity from the energy efficiency to charge vehicles, the savings in vehicle miles traveled help make it possible to fund those deep energy efficiency retrofits. So this is where using the whole household budget, not one thing at a time, makes sense. All of this can be done under most of the codes. We have a very interesting financing and governance model. We're using CFDs, which is a community facilities district for the infrastructure, PACE for the improvements inside the homes. We're using the JPL to create a eco-block trust to organize the whole thing. And that's what we're going to do in the first one. I'll go quickly to the last slide. We're currently selecting the final block. We're going to establish all of the necessary legal entities. Here are the questions. What will be the real level of cooperation from PG&E? Big question mark, although they've been collaborating with us. Is the neighborhood trust with the CFD and PACE the best long-term governance and financing model? Would a third-party design, build, own, operate, maintain be a better model, especially if they make money, which we think they can? Or would PG&E decide to change its operations and use this as a way to rebuild its infrastructure? So, in conclusion, while the integrated systems thinking works technically and across the financing domains, it really has to do with the biggest challenge is the legal, institutional, and social governance models for these kinds of neighborhoods. That's, I think, the work we have ahead of us. The technology we know works. It's how we organize to implement it. Thank you.